Hello and welcome to TidyX episode 186. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name is Patrick Ford. Thanks for joining us here at TidyX. As always, be sure to like and subscribe down below. And if you enjoy the work and you'd like to support it, we do have a Patreon page. Thankful for everything that you might want to give to support this work. That said, we're going to jump into this week's episode talking about the camcorder package, which Ellis recently rolled out and displayed live at PositConf. So
Yeah.
he'll tell us a little bit more about it. We can see some of the cool animated plots working for us right there in the window.
Yeah, a few weeks ago I presented at PositConf. I was thrilled to be able to go and talk to a great crowd. In it, I was talking about how I created camcorder with Georgios and Cedric, and how it benefited them. And I figured I showed examples of how camcorder could be used, but I didn't take the time because I didn't have the time to go through and explain how the actual code works. You know what we do at TidyX all the time. So I figured over the next several weeks, as Patrick and I have time, our lives have gotten rather busy over the next last several weeks here, but try to explain to you all how we built or how I built these and how they function, so that you have a better idea of not only could it be used this way, but how you can apply camcorder, to your data sets and how you might be able to use this. And so we're going to start off with a relatively simple one, which is the Gapminder data set. We'll get over to the comparing the different chick weights, potentially get over to the flame tree example, which I think is really, really cool. And then the pièce de résistance, get to the blockbuster animation that I showed during the presentation about combining all these different pieces together and how you can use patchwork and camcorder and all these really cool tools. So without further ado, I'm going to close these out and we're going to get going on the animation for the Gapminder dataset. And so if you don't know, Gapminder is a project where they record a bunch of different statistics across a lot of different countries and show them over time from like the early 1950s until till now, for us to kind of get a better idea of how is the world doing and what are the gaps between the different countries and how are countries improving or changing over time. So it's a really great project, and it's really focused on the data and what does the data show us. And there's a really famous animation of the Gapminder data set showing the different countries' GDP versus life expectancy over the years. And so I recreated that using Camcorder and the Gapminder data set. And so we have library tidyverse for our data manipulation needs. While then we have the library camcorder, which you can, of course, install from CRAN, which does the recording. And then we have the Gapminder library, which has the Gapminder data sets included in it. So we're going to just load those three, and we're going to skip over this portion. We'll get back to that in a second, because first we're going to explain to you how you actually make one of those plots. So I'm simply going to grab the first year here so that we can demo this. So this is from the Gapminder dataset. Grab the year column, get the unique values out of it, and sort it. So if we run that, that'll give you the years that this dataset has. And I'm just going to grab the first one. So use the double square braces 1 and assign that to plot year. All right, now that we've got that, what we're going to do is now we're going to take that Gapminder data set and filter it on year to keep only the year of interest. So in this case, it'll be 1952. So we run that and we end up with a data set that looks like this. So we've got the country, continent, year, life expectancy, population, and GDP per capita. All right, Patrick, how would we go about creating a plot, the Gapminder plot for 1952?
Yeah, so we're going to create the plot for 1952. And then, like Ellis said, we're going to utilize the for loop to basically create every plot in sequence of those years. So the best way to kind of describe what we're doing inside of this for loop is we're drawing each picture from the, like when you were a kid, you had the little notebook and you'd flicker through and you'd see like Mickey Mouse move across the page through each page. So that's essentially what we're doing.
Yep.
So to create one of these plots and then loop over them to create that little Flickr notebook, we're going to use ggplot and we're going to pass it our Gapminder year filtered data set. Then after that, it's pretty much standard ggplot fare. So it's going to be a geom point plot. We have on the x-axis the GDP of the countries, and on the y-axis the life expectancy. The size of the points is going to be the population size. So larger populations will have a bigger dot and be more representative. They'll stick out better. And then we're going to color by continent so that people can decipher which continent they're actually looking at. Alpha 0.5 just ensures that the coloring of each of these points have a little bit of clearness to them, so that opaqueness, so that they don't cover each other up. Another thing we're going to do on the x-axis, which is very common, you can obviously see how the data looks there. If we scale, log scale the x-axis, log scale the GDP, that's going to help constrain outlier values and get everything a bit more compressed together so that it looks more reasonable like we see now. On the y-axis, we're going to set some continuous limits between 20 and 90 for the life expectancy, just so that we don't have any sort of like weird open spaces at the, create some open spaces, sorry, at the top so that we can see things together, because ggplot is going to manually set your X and Y limits based on the content of your data. So we just want to create a little bit of space, a little bit of buffer so that we can see things compressed together a little more. Then down here, scale size, this is,
This is for the points themselves. So you can see here, like obviously it's not super linear, as well as trying to make sure that the dot size is more impressive, right? Where the higher the population, the bigger the dot. But by default, it scales the scaling isn't really large. So by setting this scaling to be a little bit higher, we're then able to see it more intensely.
Yeah, so
So
you can always set the scaling. I do this a lot with different things, especially like if you're dealing with sports data and you're dealing with, like, let's say basketball players and number of shots across a season or something like that. Again, ggplot, just like the X and Y axes, they're going to set the scale of these points. And so you can kind of reset those scales to whatever you want to ensure that, like, hey, I want this to make sure that it is actually the biggest point and this to be the smallest point. And then it'll kind of coordinate everything in between. And so there's a number of different ways that you can do this.
yeah, and
You
a
can
lot of
also,
this is also being done because we're going to be looping across multiple years as well. I didn't want it to be jittering across, like, from 1952 to 1967 or something like that, for the scales of the y and x axis to change, as well as the scales of the population, because then it kind of pulls you out of the animation part of it and the recording, and all of a sudden you're like, wait, why are the scales changing? And we all
yeah,
know changing scales in an animation kind of confuses the viewer, right? And the person that's trying to interpret it, but they're not only having to look at the, like, trajectory and changes of the values themselves, of the, like, dots that they're interested in, but also how are the X and Y scales changing during that same process. And so, I mean, if you're trying to hide something, yeah, sure, but probably shouldn't be doing that. If you're trying to do that, like, think about what is the impact of that, right?
yeah, and that's a good point. Since we're going to be looping over these, if we don't set any axes or size parameters, essentially it's just like flicking through each individual plot on its own. And really, we want to make sure that one plot leads logically to the next. And so you have to set these scales. The final thing we have here is going to be our labels. So we're going to have a title, Gapminder, and then we're going to pull the plot year from the for loop for whatever index that we're pulling from, obviously. So that'll be a nice looking little title there. GDP on the x-axis. On the y-axis, we have life expectancy. We're going to want to just, you can see over on the right, the picture there, you can see legend title is continent in lowercase. So we can just obviously style that up. You can do that with guides right there. And then I think you could also do it in labels if you did color equals continent.
We can test that right now.
Yeah,
Live coding.
I'm pretty sure this should work.
Let's comment here. Let's just
Like
run
that.
this.
Well, just on there. Yeah. This. Yeah. So
Positive.
you
All
could
right.
do it there as well. Either way, if you want to save some code, the lines of code, either way. And then we have a bit of theming down there. So this is just the the basic theme stuff. Where do we want the legend position? Let's go ahead and throw that at the bottom. We have some title size information. We have some axis title size information, and we have the legend title size and the text size information. And then at the end of this, I think we've talked about this before in for loops for ggplots. For loops, you just got to drop that print in there. So you're going to print it, and now it's going to print each one of these when we click playback. So now let's go ahead and take a picture of every plot in the
Yeah.
sequence.
So the way that we go about doing that is in Camcorder, there's a function called ggrecord. And ggrecord starts the recording of every single plot that you generate from then on until you tell it to stop using either ggplayback or ggstop recording. So in ggrecord, when you set that, you don't have to set anything. You could potentially just call ggrecord and call it good. Like that is perfectly legitimate. But I tend to, and the folks that I know that use this tend to want to specify a number of things before they go. And they don't like to use the defaults necessarily. The defaults are good, but you can override them. So by default, it goes to a temporary directory. If you want to go back and potentially in multiple sessions do it, you specify a directory. And so here we're going to say Gapminder over time. The device is what type of device are we going to be saving it to? Is it going to be PDF, SVG, WebP? What is the type that you want to be saving it to? Default is PNG, and we're just going to specify that here just to be like clear what's going on in case for some reason we change the default in the future. The width and height of the plot. So this is very similar to like ggsave. I mean, functionally behind the scenes, it is calling ggsave. So we're going to set the width of the plot to be 15 inches and the height to be 8 inches. As you can see here, that's going to make it like this plot lends itself to being a wider than versus taller plot. So we want to set the width to be almost double the height. We set the units for those to be in inches. And DPI stands for the resolution. So how many points per every inch exists. And so you can get pretty crazy, but the more DPI you have, then obviously there's more bits of information per inch, which means it just the files themselves tend to get just really large from that. So then once we call ggrecord, it goes, hey, FYI, I've already got some content in there. That's because I'm using the files that I pulled down and created for my presentation. So I'm not going to actually run it here. But essentially what's going to happen now is it's going to, now for every single plot that we create, I'm just going to print this. It's going to allow you to view this as it's actually being shown. Using these settings here, it prints it out for you. So you can go in and zoom in and see this is exactly as it was created. So we can see the resolution, we can see the way the text appears and whatnot. And if we we're just gonna run this because it's under version control, so it's fine. We can revert it, and so we can see that now it plotted from 1952 all the way to 2007 every single plot that we had. Now, when we're done with that and we want to convert it from, okay, we've got a series of plots that show from 2000 or 1952 to 2007. We could go and we could look in this would be the Gapminder over time thing here. We can see all these different plots, so we can look at what was done here. So this is from 1967, the Gapminder data set. But say we're done. Now we want to convert this into our animation, because right now it's just a series of plots that are saved as PNGs. We call the ggplayback function. ggplayback will both stop it recording now, so any plots that you create in the future will now no longer be saved. Then you pass the file name you want to be saving it as, it must end in .gif. The duration of the first image, so how long you want that first image to be shown, how long you want the last image to be shown, and how long each frame should be shown for. And so here I'm saying for the first image, show it for 1 frame. For the last image, show it for 5 frames. And every frame should be 1 second. So by default, frame duration is in seconds. Image resize. So this is how much should you scale up or scale down the image in pixels. And then last is first is asking, do you want to have the last plot shown in the very beginning or just have it wait until the very end? Because sometimes people like to see, the very last plot be shown and then the creation process, because that was what Camcorder was built for. So by default, that's true. We're overriding that to be false. And so if you run this, this is going to be, what we're going to do is we're going to just delete all of these because we just created those. Sorry for that bing there. Now we run this. That's now going to resize all of these plots here, and you can see it's now creating the GIF, and we just got that same animation that we had at the very beginning. And so it's showing Gapminder from 1952 to 2007, plotting. You can see the various countries and the various continents and how they're changing over time. A Gapminder also does have this is every 5 years. They do have every data for every year as well. I just chose not to do it in this situation. And so you could have it really smoothly show from 1952 all the way to 2007 every year and really create an animation that could be really compelling. But that's how you can create a Gapminder animation using Camcorder, using some simple tidyverse, the Gapminder dataset in Camcorder. Leave a comment down below of what animation you want to see us do next. Do you want us to do the chick waits? Do you want us to do the flame tree animation? We're going to be holding off on the blockbuster, but we want to know which one of the other two you'd like to see. Or what are cool ways that you could think to use Camcorder as well? We'd love to hear it. And if you've got a great example and you want to share it with us, we'd love to see it. Patrick, do you have anything else to add?
Nope, pretty dope. Pretty
Yeah.
sweet. Yeah.
Cool. Well, we look forward to doing this series here on Camcorder and what we presented at PositConf. If you want us to also do a quick review of the PositConf, leave a comment down below as well so we know whether you want to hear that or not. With that, we're going to end this episode of TidyX. Thank you all so much for joining us. As always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick, at tidy_explained is where the screencast lives on Twitter or X or whatever it's called these days. But easiest way to get in touch with us is, of course, the YouTube channel. Like, subscribe down below. There is also a link to the Patreon page if you enjoy the work and you would like to donate to the show. That is open, and we're thankful for anything you'd like to give.
Thank you all so much, and keep on exploring your world.